So what do you see the difference between this one and the last two that we did? It's division. So anybody remember? You keep. I'm just going to write, because you keep this one, I'm just going to write this one out. Okay, so the first fraction you keep. You change the division to multiplication, and then you flip this upside down. So the denominator becomes the numerator, so it becomes 7 times A times A times B times B. And then it becomes 24 times M times M times M. Again, whenever you see the division problem, you keep, change, and flip the second fraction upside down.
So why change the multiplication?
Because anytime you divide fractions, you always change division and flip it upside down. Old school rule when you used to add into multiply regular fractions and divide regular fractions. Okay, so now we're going to reduce, okay? Can you reduce 16 and 21? Does anything go into 16 and 21? So nothing goes into 16 and 21. Can I reduce any of the variables up and down? Okay, what about 7 and 24? Can I reduce 7 and 24? No. Can I cross cancel up and down with the variables? Now I'm going to go diagonal. 16 and 24. Is there anything that go into 16 and 24? 8. Okay, so 16 divided by 8 would be 2. 24 divided by 8 would be. Now variables. I have an M here. Oh, I have an M here, so we're going to cancel out an M. Do I have any T's diagonally? Okay. Now we're going to go the other way diagonally. So 21 and 7. Can you reduce those? Okay, so what can I reduce by? So 7 divided by 7 is, and 21 divided by 7 is, I have 2 A's here, and then I have 2 B's. Now our job is to multiply straight across the numerators and then straight across the denominators. So I have 2 what? 2t squared over is there a b? Did we have an extra b? So a squared, b, m squared, and this is your answer. Any questions? What questions do you have? Okay, so this is different than the one we just did, and I want you to know how it's related to the division. In a division problem, you would see a division sign there. So in that one, you would leave, change the division to multiplication, and then flip this upside down. Okay, so they follow the same suit. So what we have to do is we're going to have to factor. Factor the top, factor the bottom. So we're going to look at the top. There's only 2 terms, so that means it's probably a GCF. So what can I pull out of 8x minus 20? What goes into both 8 and 20?
4.
So I'm going to write 4. And then that means I'm left with 2x minus 5. What are 2 numbers you can multiply to get negative 35? Negative 7 and 5. Which one? Well, you can either have negative 7 and 5 or 7 and negative 5. Which one gives you positive 2? So this one right here. So I'm going to write x plus 7 times x minus 5. Now I'm looking, now the reason I can factor it like this, you guys, is because there's not a number in front. So two numbers you can multiply to get 10. When you add them, you get -7. Okay. Okay. Do these have anything in common? 4. Okay, now there's two things that this one happens. They're also a difference of squares. How do you know that, Miss Fleury? Because 4 is a perfect square, 16 is a perfect square. And if I pull 4 out, I'm left with, so I just want to show you a little bit before you write this one. So I pulled the 4 out, and now I'm left with a difference of squares. A difference of squares means that the first term is a square, there's a subtraction sign, and the second number is a perfect square. So I'm going to write it as 4, x plus 2, x minus 2. Those things you're going to have to be able to start recognizing. So you're going to have to recognize your perfect squares. Oh, hey, that's a perfect square. Can I pull something out? Those are the type of things. Okay, so now let's start crossing out. Can I cross out anything up and down? They're in parentheses. It has to be matching parentheses. Anything I can cross up and down here? What? So I'm going to cancel these out. They have to, if they're in parentheses, they have to match. Let's go diagonal. Is there anything from this side to this side I can cancel out? The 4s. Now, we'll talk about what happens at the end. Okay, now is there anything that I can cancel out diagonally this way? Now, what am I left with? What happens if I miss that? Well, when you get down here, when you get to your final answer, you might notice that, oh, I could factor that one more time. So you guys, when you get to this part, if you miss a step, when you get to your final answer, check your final answer to make sure there isn't anything else you can factor. And you would have noticed down over here, when you got to this, you would have noticed that you would have had 2x minus 4. You would have noticed that 2x minus 4, you could have pulled a 2 out. Like, things would have started showing up. So if you don't get it right away, this is why we're practicing. Okay? Now we're going to do... So when you see a fraction over a fraction, this is what we call a complex fraction. What we're going to do is we're going to rewrite it. And you guys, when you go to take the ACT or the ACT or SAT, they love problems like this. That's what that means, okay? So anytime you see a complex fraction, it means this fraction divided by this fraction. Well, what did we just learn? You keep, change, flip. So we're going to keep this one, so let's factor it. You guys, what does x minus 2 squared mean? What does that mean?
X minus 2 and x minus 2.
Yep, that's what that means. This 2 is going to stay out here. And then what are two numbers you can multiply to get 4 When you add those same two numbers, you get negative 5. Yep, negative 1 and negative 4. We're going to change the division. Let's go up. We're going to change the division to multiplication. And now we're going to flip this fraction upside down. And I just did that to the side so that I can factor it. So I'm going to factor 4. So remember, I flipped it upside down. That's what I did over here. Now I want to write it in factored form. So 4 is a perfect square. Is 10 a perfect square? And there's no x squared, so it's not a difference of squares. Does 4 and 10 have anything in common? So I'm going to pull out a 2. And then what am I left with? You got it? X squared minus 4. X squared is a perfect square. There's a subtraction. Is 4 a perfect square? Then that's a difference of squares. Now, let me say, you guys, anytime I have two terms and there's a subtraction sign, I always make sure if it's a difference of squares. Okay, now can we cross out up and down on this fraction? X minus 2, x minus 2, x minus 1, x minus 4. Nope. Can I cross up and down on this fraction? Okay, so let's go diagonal. I have an x minus 2 here. I have an x minus 2 here. Is that all I can do diagonal that way? Okay, now let's go diagonal this way. I have the 2. Anything else? My final answer would be x minus 2, 2x minus 5, and that's my final answer. If I asked you to do the restrictions, you guys, you would do the restrictions before you multiplied, before you did anything. So at this moment, right here is when you would do the restrictions before you start crossing out everything.